One of the things that I love looking at is Siberia, a place I've never been. It's vast, vast forest covering, so much of that boreal domain that we have almost no data in because it's really difficult to get there. But being able to see it in high resolution and zoom in and see what's going on in those parts of the world that we could never visit by foot, it's really cool and exciting.
Forests play a crucial role in balancing Earth's carbon budget, absorbing and storing roughly 30% of atmospheric carbon. However, vast regions, like Siberia's boreal forests or the Congo Basin's tropical forests, have been a mystery because of the obstacles we face in studying them up close.
For, over 50 years now, we've been looking at forests from space. The longest record is from the Landsat program, where we have, these high-resolution images month after month showing us where there is forest, where we're losing it.
But there's something we still don't fully understand: how much biomass we've truly lost. Biomass is the total mass of living things in a given area.
If you were to cut down a tree and dry it, about half of the dry mass of that tree is pure carbon. So where we've seen historic losses in forest, we haven't known how much carbon was actually lost as part of that. But in the forestry domain, there is that hope, and it's actionable.
Meet JEDI. Mounted on the International Space Station, it's the first satellite LiDAR system specifically designed to measure forests in 3D. JEDI maps tree canopy height, forest structure, and surface elevation, giving us an unprecedented and incredibly detailed view of Earth's canopy structure. This allows us to measure biomass and the carbon stored within. But it has one major limitation.
It had this huge data gap in the boreal because the International Space Station doesn't go over the poles. So essentially we have amazing data from JEDI over the tropics, over the temperate forests, but the vast majority of the boreal was just this huge data gap.
That's where ICESat-2 comes in.
We're so lucky right now with the forest LiDAR community that we have ICESat-2, which was not designed primarily for forests. The lasers are different, but it's still collecting really useful 3D forest measurements.
ICESat-2 fills in these spatial data gaps by obtaining different measurements at different rates, giving us a more complete picture of global carbon storage.
So these two LiDAR systems that NASA is currently operating, JEDI and ICESat-2, they're really quite complementary. They're in different orbits, and so their transect across the ground is a little bit different, so it captures different parts and different densities, as you will, within the mid-latitudes.
By combining data from JEDI and ICESat-2, scientists can create a first-of-its-kind global biomass map. Now, we're able to track where carbon is being lost and where it's being regained as forests recover or new trees are introduced.
So then, after we have JEDI and ICESat-2 on orbit, we can assign estimates of how much carbon is being lost or sunk back into those forests as we see them change over time. So we're uncovering all sorts of forest carbon stories that we've never had the data to do before. What you want to do is say, here's where most of the habitat is for biodiversity. Here's where most of the carbon is. These are they're the highest priority places for conservation. These are the best places for potential restoration, right? So we can use these satellite products to help guide decision making, but then also provide this check to give us a sense of how well we're doing over time.
Using this knowledge, NASA provides critical insights that help decision makers take action in protecting and restoring forests, strengthening one of Earth's most biodiverse and carbon-rich ecosystems. With JEDI and ICESat-2, we're not just looking at forests. We're seeing a global picture of our planet's carbon cycles, impacts of forest management, changes in forest cover, and the future of our planet's carbon balance.
We really can make a positive impact there, and we need these NASA missions to do that.